So we'll talk about, you know, this training program is about Spring Framework. We'll talk about Hibernate mapping, and we'll talk about microservices. Right now, what is Spring Framework? Or popularly called as Spring MVC framework. Right? See, Spring Framework is basically a web-based framework. Whether it is JSP, Thymeleaf, Velocity, FreeMarker, any templating language, it's a web-based framework, which helps us develop web applications. That is the definition of Spring MVC framework. It's a web-based. Web could be, it could be React, it could be Angular, it could be JSP. We'll talk about JSP from the Java point of view, right? For developing, for creating web applications. That is the definition of Spring Framework. And as the name suggests, this Spring MVC framework is based on MVC design pattern. MVC stands for Model View Controller, right? So it's a web-based framework to develop web application, and it is based on MVC design pattern, Model View Controller, right? Basically, in Spring Framework, request comes from view, which could be React or Angular or JSP. Request comes from view. Then request is intercepted by controller, where the entire business logic resides or business functionality exists, right? So request will always come from the front end, view, right? And then it is intercepted by the controller, where every business functionality exists. It's a middleware, right? And whatever application logic we have to write, we write in controller. Now communication between React and controller happens through model objects, model or entity. There is a there are tables in the database. So related to that, we create a Java class. We create an entity class, in Spring Framework, which holds the entire data, which holds the data for our application, for application flows, for application functionalities. So request always comes from view. It is intercepted by controller. Controller is that particular class in Spring MVC framework, which holds the entire application logic, and it puts data in model or entity, or people call it as domain entity also. What we are dealing with in a web application, product, let's say tutorials, or let's say task, or any customer related data. So ultimately controller gives the response back to browser. So controller return back the model object, or you can say data from the model object, right? Data from the model object is finally returned to, or is displayed back, or returned to the front end, the browser, which is the view. This is overall MVC design pattern. Request comes from view, which is, in our case, it is going to be JSP. It's intercepted by controller, where every business functionality resides, application logic resides, and the communication between controller and view will happen through model object or entity or domain object, or you can call it as Java bean, right? Or a simple Pojo class, plain old Java object class. And ultimately the data from the model is displayed back as a response, right? Is displayed back as a response or returned as a response to the browser. This is what MVC design pattern is. Okay. So Java server page, JSP, which will help us display the content on the front end. Right? JSP, Java server page, or a view which will ultimately display the model object data or the content on the browser, right, which will ultimately show. Okay, so this is MVC design pattern. Okay, now there are certain characteristics, there are certain features, right, there are certain salient features, important points about about Spring Framework. That's the reason it is so much popular. One crucial feature or most important feature of Spring Framework is inversion of control, IOC, inversion of control, which means that in Spring Framework we don't have to create, instantiate or initialize objects, right? Let's say we will create a controller class, right? In a Spring MVC framework we'll create a controller class. Now the object of that controller class will be created, will be created by, there is one single object in the entire project which is called as Spring Context. So we'll create, as a programmer we only have the responsibility to create Spring Context object. Then Spring Context will create the controller objects, the model objects, whatever service, repository, whatever we are using in our project, all these objects will be created by Spring Context object, and those objects will be available to us, will be available to us at runtime, right? Runtime of the application. Okay, all the objects will be available because of Spring Context object. Because of one single object, the entire classes object will be created for us, and it will be instantiated also, right? So all of them will have the value. It could be null, but every object will have the value, but every object will be created by Spring Context object. So it is inversion of control. Control is inverted, and Spring Spring Framework does that. That is why IOC, inversion of control. All objects will be created by a Spring object, Spring Context, and every object will be instantiated by Spring Context. Right? That is one important feature. Then there are other features. For example, there are different projects in Spring Framework. We'll talk about Spring JPA, we'll talk about Spring REST, even aspect-oriented programming. They can be very easily integrate with one another, right? There is no problem with that. Integration between different components of Spring Framework, different projects of Spring Framework can be done very easily, right? So whatever we want to use for Spring Cloud, Netflix server, everything can be integrated. What we need to do is just give the dependencies in pom.xml and give certain configuration in application properties. Thereafter we can just use the APIs properly. Okay, we'll see all that. We are just trying to understand about this framework right now. Okay, and there is another feature which says there are no rules or foundations. There are no specific rules that we have to follow. Here we don't have to particularly extend a particular class, or we don't have to implement a particular interface. Things are not mandatory here. So adaptability exists with Spring Framework. Spring Framework is an adaptable framework, right? So we have learned till now that Spring framework or Spring MVC framework is basically used to develop web applications, right? It's a web-based framework to develop web applications. Second, we learned about the MVC design pattern, that request comes from view intercepted by controller and model holds the data for the entire application. Then we understood about inversion of control, that in Spring framework objects are created and initialized by Spring context object. Right? In Java we have to create objects using new keyword, then with the help of object we call the methods. Here we don't have to do that. Right? Then there are other few features. For example, entire functionality of Spring MVC framework or Spring framework is built on Servlet JSP API. So all the knowledge of our entire knowledge of Servlet JSP, if you know about HTTP servlet request or HTTP servlet response, everything will be used here. Session based programming, everything is used in in Spring framework. Right? So Spring framework is built on top of Servlet JSP API. Right? So all that knowledge will not go waste. Okay? Then as I told you that here model object holds the data, which is a simple plain old Java object, POJO. Private fields, getter setter method, no argument constructor. That's it. That is why it is considered as a very lightweight development, right? Because of this POJO kind of functionality which model object holds. I'll show you how easily we can transfer the data between view and controller. Right? I'll also tell you how URLs are mapped in REST API. I'll also tell you how different themes can be applied across different continents wherever our application goes. I'll also tell you how validations are applied, about first name, last name, username, password, different radio buttons, different combo boxes, all that I'll show you. Okay, and most importantly we'll also talk about Spring REST, where we'll talk about HTTP endpoints, and we'll make use of Postman tool to verify our HTTP endpoints, our functionality, whether those endpoints are able to get, put, post, delete, get all from the database or not. We'll see all that, how different endpoints can be configured and how they can be tested. Right? We'll also try to use JUnit for the testing purposes and Mockito framework for testing our HTTP endpoints. Okay, so these are some features, or these are some points that we'll see, and why Spring framework is so much popular because of them. Alright, so before we create our first project, let's understand the entire architecture of Spring framework, of Spring Web MVC framework application. There is an architecture followed by every Spring MVC application, right? Every Spring MVC application. I told you that request always comes from the view, right? View JSP is the client. Request always comes from view, right? Request always comes from view. Then before the request is handed over to controller, who hands over the request to controller will create one dispatcher servlet. We'll use one dispatcher servlet. A server side, there is one AP. This is one servlet class, which is the main star of a Spring MVC application, which transfer the request to a particular controller, because every controller has got one URL endpoint. There is one URL pattern on top of every controller method, URL pattern. So dispatcher from view, we may send something like this, and dispatcher servlet will transfer the request to a controller. All we need to do is, in Spring project we have to configure one Spring context object which will initialize and create all objects, and we have to configure dispatcher servlet also. then the request will start going from JSP to controller, right? And then the controller can use the handler mapper for, let's say, images or CSS files, for all for all configuration related things. We'll configure that also, right? Then controller can talk to a database, to other system, to cloud programming, right? So controller can talk to database. We'll use MySQL database to update, to get, to delete, to post, right? So controller can use REST calls, REST services with the database. And then ultimately controller will use a concept called view resolver. Controller will use view resolver. In our case, we will see internal resource view resolver, or we'll see XML view resolver, or we'll see resource bundle view resolver properties file, to know which JSP to go back to, to know the front end part to go back to, right? So overall, this is the architecture of every Spring application. That request comes from view. It could be JSP. In full stack, it is React or Angular. Then it is intercepted by dispatcher servlet. Dispatcher servlet, it's what we need to configure with Spring context, and then it takes the request to controller. Controller can talk to database, controller can talk to REST services, other services, but controller can use the handler mapper. This is handler mapper, right? Which gives us the access to all images, all CSS file, any JavaScript file is being used, all that we can use. And then controller knows which JSP to go back to using view resolver. So from controller, you must have seen a string being returned like this, right? So controller uses this view resolver to know where shall I go to find this name of a JSP in the project that we are going to create. Okay, so this is the basic understanding about Spring Framework. What Spring MVC framework is: a web-based framework to develop web application. We have learned what MVC design pattern is, on which Spring MVC framework is based on. We have understood some features like inversion of control. I'll tell you what dependency injection is, how we use every class so easily in other classes like service or controller classes, and all projects of Spring Framework can easily integrate with one another. And that here we are not bound by, or we are not fixed to a particular rules. And this architecture will you see the use of dispatcher servlet and Spring context object. Fine. Till this point, understood? You can just message me. Till this point, is it clear? Okay, yeah. So now we'll create our first MVC project, right, to see this working. So to create a Spring MVC project, and after that we'll create a similar project with Spring Boot, right? First we'll create a MVC project by ourselves, and then same project we'll create with the help of Spring Boot. Spring Boot actually just gives us the production ready applications in a very faster way. You'll see that it has taken the initial part on its own. We'll see that. But first let's create a project. So to create a project, let's say I'll go to IntelliJ, and here I say new project, right? And I can use a archetype Maven. I can name it as Spring MVC, right? Spring MVC, right? It will go under downloads folder, and I'm using Java 17. You can use any version of Java. I'm using this Maven archetype web app. This will give us the basic architecture, of the project. Now this is the group ID. Every organization has its own group ID, like org Tomcat, org Spring Framework, Commons, right? These are just the package name. For example, I can just say, let's say com dot spring concepts. I can name it like this. This will be the package name, and this is the name of a project. This is the version, first version. As and when you add more concepts, versions keep increasing, just to keep track on what goes in GitHub and all that, right? So after that, I'll just say create, to create a project, right? So when I'll show you Spring Boot, there I will show you don't have to worry about every dependency. But here earlier, we have to take care of the dependencies by ourselves, right? Here we have to take care about the dependencies. Okay, so I am just going to add few dependencies, because in Spring MVC we have to add it. So total 5 dependencies we need to set up a basic project. So JUnit dependency is already given to us, right? I am going to create a basic Spring MVC project. So I need org Spring Framework, artifact ID I need is Spring Web for all annotations and web-based APIs, right? So org Spring Framework, Spring Web, and I can use this release of this version of Spring Framework. Now all these dependencies will come from Maven repository. If you search, this is how it it works, that it gets the Maven dependencies. If you search it, this is the repository where all dependencies exist. So whatever we are mentioning, it is coming to your .m2 folder. All the dependencies basically come in your repository folder in your local environment. When you keep working, your system will keep getting that, right? So here first I mentioned web, then I need to mention the web MVC for the controllers and controller based annotation, same 5.1.9 release. These two related to Spring, the other 3 are related to Servlet and JSP. It's a Spring MVC project which we are creating by ourselves. In Spring Boot we don't have to worry about all that. So JavaX Servlet, API, and version number is 3.1 or 4.0 also I can use, right? This is third dependency for Servlet, fourth dependency for JSP. So JavaX Servlet dot JSP, JavaX Servlet dot JSP hyphen API, and version number for JSP is 2.3.2 B02 beta version, right? One last for JSTL, for verifying our JSP files, Java standard tag, Java server page standard tag library. So JavaX Servlet, this artifact ID or the name of a project or the name of a jar file is JSTL, and version number is 1.2. After doing this, I'll just say Maven refresh, right? So all these dependencies, you can see it is happening below, right? Now how the build will be created, that also we have to mention. So build final name has come, but I need to add certain plugins. Plugins will have plugin. I just need one Tomcat plugin, then all the builds will be created, right? So I can, in the plugin I can add the artifact ID. Let's say I need the Maven War plugin, and I need this version 3.0.0. I need this plugin, Maven War plugin, and one more plugin, the Tomcat plugin, which will compile and deploy also. I don't have to worry about deployment also. So group ID is org Apache. After Apache I need the Tomcat one and the Maven, and then the name of the dependency or the name of the jar file which will help us compile and deploy our code on the Tomcat server automatically is this Tomcat 7 Maven plugin, and the version number for this is 2.2, and I can mention the port number also. Configuration, I can mention that this particular project will, let's say, work on 7061. Right, I'll just click on Maven refresh to add this plugins from Maven repository in my local, or I can click this refresh button. Right, it will come. I'll just save this file. So I have added two plugins, one Maven War plugin, and 3.0.0, and this Tomcat Apache plugin. Okay, then comes the project. So we have to create one Java directory first in the Spring MVC framework. Right, under this I can create the same package name that I gave initially as part of the project creation. We gave the in pom.xml, you can check here I gave this package name com spring concepts. So under Java I can create this package com spring concepts, and under that I'm going to create one Java class. I am going to create three Java classes, one for the application starting, second for configuration, third first controller. So to initialize the application, which we don't need to do in Spring Boot project, in Spring MVC project we have to do this by ourselves. In Spring Boot project you will see that I don't have to do this. Right, here I just need to tell how the project will start. This is the starting process for every Spring MVC project, no matter which organization it is working in. Annotation config web application context. This is the Spring context object I was talking about. All we need to do is create this object, annotation config web application context. Right, and to this context object I will register one configuration class which will have the handler mapper and the view resolver which dispatcher servlet needs. So right now it will give us the error. Right, once I will create this class, this error will be gone. Third is to create the dispatcher servlet, which we create with the help of servlet registration child interface, the dynamic which comes from the if I take the servlet registration one, right, and object name is servlet registration, the method parameter servlet context, add servlet, and I'm going to create a dispatcher servlet with the name MVC. It could be any name, and to this we will pass this Spring context object that we created. Now we will say this will be the first servlet to start, set load on startup, first one, and we are also saying that this will handle everything that comes after slash. Right, now to get rid of this error, I will just create another class application config. Now this error is gone. Okay, so here this is application initializer which implements the web application initializer. Right, okay, now this is the initialization. In Spring Boot project we don't have to worry about this. Annotation config, that here we don't have web.xml, we will have the configuration class, this configuration class. That is why I created this object. Second, we configured this class with this object. Third, we created a dispatcher servlet. We handed over our context object to dispatcher servlet. Dispatcher servlet will be created with the name MVC. This will be the first servlet to start on load and add mapping. Everything after slash will be handled by the Spring Context and dispatcher servlet. Now comes the configuration, which will have the handler mapper and the view resolver. Right, so we'll write one @configuration, and we'll also, this particular class will automatically scan all controllers. So all we need to tell is base packages, this particular package I copied, this is base packages. It will automatically look for all controllers, component and service classes. It's a child of web MVC configuration support, and it will have that method add resource handler. Right, now to this method we will tell where your CSS and the images resides. I'm just saying look for the CSS and the images folder directly in the class path, which is under resources. So all CSS like this. So we have mentioned where to look for the CSS and the images. Then comes the view resolver. We create an object which will be created by the context object, Spring Context object. This internal resource view resolver. This Spring Context dispatcher servlet needs this to find out the name of a JSP which the controller will return. Right, so view resolver set prefix, that you need to check the web-inf, and under that JSP folder. Don't forget any slashes, otherwise your JSP will not be found out. And after whatever controller returns, put dot in JSP in the end, and the JSP will be compiled by JSTL view class, for which we added the dependency in view pom.xml, project object model, basically, which controls what our project needs and what our project doesn't need. So here we mentioned under resources you will have the CSS and the images folder. So I will add CSS and the images which my index.jsp needs to display a better web page. And under web app I have web-inf. Here I am making a directory called JSP because my internal resource view resolver is saying index.jsp resides under JSP folder. And I am deleting this web.xml because it's a configuration based project. That is why I used annotation config web application context. So it just prints the hello world message. I will create just one controller. I can name it as anything, home controller, and I put controller annotation on top, and I can create one method which returns the name of a JSP, show home page. All it does is just this home, index. Now URL pattern. How dispatcher servlet will find out this. So here we need to use the get mapping. I need to mention if slash comes, you need to show the index. Index resides under web-inf JSP, which we have already mentioned here, that under web-inf JSP this resides. Right, I can mark Java as sources root, where all code resides. And here I am not putting CSS and images right now. Right, I just mentioned that under class path, you know, this CSS in the images folder resides, and this is the location. So this is the initialization, dispatcher servlet, that's it, right? pom.xml has got, you know, even if I don't get the Maven War plugin, you know, I just comment this out, we can compile our code through. Okay, so that was the reason. This, I don't need this plugin. So Maven War plugin, you know, I can compile it with the Tomcat plugin only. Artifact ID, version 4.0. Do they have 4.0 now? Downloading plugin. Now it is downloading that plugin. I could have done it with this this Tomcat plugin itself. They might have deprecated this plugin, so I'm commenting this out. Right now I will just clean the project, and the project will work on 7061, and I will install all the dependencies, and the build will get created. Here some error is there. Option 5 is no longer specify the language version. Here 17 is there, right? And here okay, so now let's see whether build gets created or not. org Apache plugin in pom.xml, this org Apache Tomcat plugin, I added this org Apache Tomcat Maven, Tomcat 7 Maven plugin 2.2, org Apache Maven plugin War, right? Otherwise, if I add this plugin without Maven War, or I can add the group ID, this Maven War plugin, what versions do they have? Do they have a specific version? Otherwise, if they are only available, okay, so I'll just check the project settings. 17 only, 8, sorry, this was the problem. JDK 17. I did Maven refresh, index, okay, I do install, cannot access the default version, exception initialization, cannot access the default fields, unable to provision. org Apache, why this plugin is not found out? Google Engine unable to provision. If I copy this and just see, have they changed any particular version? Have they changed a particular version? This Maven War plugin 3.3.1 is now they are saying that it should be this one. org Apache Maven plugins. They have changed the version numbers. So build game successful. I'll just start the Tomcat server on port number 7061, and war file is successfully created under the target folder. Now they are saying child container failed to start, or even if I don't start and just run the war directly, yes, it has started the project here. I'll just copy this and I'll go to the URL and I will paste this here and put a slash sign. So here I get one exception which says failed to read candidate component application config. Nested exception is ASM class reader failed. The Java version isn't supported yet. So Java version I have provided is 17. I can increase the version to 19 and I can change the version here. If Java versions have changed, I can change it to 19. I can change the SDK version to 19. I'll just say detecting the SD version to 19. Or do they want us to run it on Java version 8? Because now Spring Boot is used a lot, right? Let us try the Java version 19, otherwise we'll try with Java version 8. So I'll just create a war file all over again with Java version 19. So build came successful. I'll just run this war file on Java version 19. So address already, I didn't stop the port number, so they got occupied. 706 this one 7061. So now I can copy this, I can go and I can just run this again. It gives the exception that version is not supported. We have to go back to the old version. This 1.8 has to be mentioned because this is an old MVC project. Nowadays everybody creates it on project structure. I'm using 1.8 SDK 1.8. apply OK. Let's again create the build with 1.8 MVC project. So build got created successfully. If I run the war file, home controller /sign, index should be returned. Index is there, and application, there is one error here with 8 override is not working. This thing, application initializer, does not work with 8. This does not work with Java version 8. Why it is not? This is a configuration component scan class, and we implemented one web application initializer. This is application initializer, right? Oh, I didn't stop it properly. I need to stop it. I need to stop the ports. Then I need to start it again with Java version 8. This hello world came. So the controller worked fine, you see. So what have we done? In the project, this MVC works with Java version 1.8, but boot will work with 19, 21, 23, all versions I have. I'll show you that. But here I created an application initializer. We created one Spring Context object which registered the application config class. This is the configuration class which tells where the CSS and the images reside and the name of a JSP. Right, if you want, I can show you a better looking JSP also. Right, I can show you the better looking JSP. I have where have I put it? In the Google Drive I have mentioned. I'll just give me a second. Let me show you a better looking page. So this is the CSS. I think I'll download the CSS. I'll share this with you. All this is already with you. CSS is there, index is there. This is index, a better looking page, not just hello world, because that is what we are going to create. So I downloaded this also. So CSS, and I need the images, right? Images, and even first class. This is actually the entire thing. So download, right? So in my downloads folder I have got the CSS, this. I'll just unzip it. So I'll just unzip it. Okay, I just unzipped it, and this is the CSS and the images. I'll just copy it and I'll paste it here under CSS. So I should have so these are the three CSS which I can put directly under CSS folder. This CSS folder I don't require, so I deleted it, and I need the images folder. I am going to delete this image folder also, and I am going to throw images here. Now I just need the index.jsp. So I will go back to downloads. I'll just copy this and I'll come here and I'll delete I'll refactor this to, let's say, show JSP, and I will paste my index.jsp here. So index is a proper training based application. So I'll stop my server. I'll just create the war file again under target folder, and I'll run the project. It will show this index.jsp. So I'll just run the war file. Right, in Spring Boot project we don't have to do this initialization thing and all that, and dependencies will also come automatically. So now when I go back to my project and I say refresh, it should, this application came on our port number. In Spring Boot this URLs are also not required. The routing mechanism is also there, right? So basically this is the view which I was talking about. This is the controller. It is not doing anything, just returning it, and this returning part is resolved by this view resolver. Images and CSS is being resolved by this resolver. Configuration class looks for the controller directly under this package, and this is the starting point of the application. Right, we created a dispatcher servlet with this name. You can see when the project started, it shows that this is the dispatcher servlet that we created with this name, and everything after slash is taken care by dispatcher servlet. Every object for controller is created by this context object. This is the basic understanding of Spring MVC framework. Later on we'll try to add annotations for controllers, for model attribute, and we'll learn exception handling, view resolver, interceptor, REST calls, and theme resolvers. Alright, we'll see all that in the coming sessions. Fine, Ravi, is that clear? Any questions? I'll upload this recording in your account. You can refer this recording anytime. You can practice this project creation by yourself. If you find it difficult to create it, you can take my help anytime. I'll help you.